All right, today's lesson is on recursive formulas. We talked about integer sequences in class, so we're moving on to recursive formulas, which starts on page 3 of your notes. So first of all, you need to understand the difference between an explicit formula and a recursive formula. So if you take a look at these definitions right here and write them down, make sure that you pause if you need to in order to get these down. So an explicit formula is a formula that you can use to find any term of the sequence, and a recursive formula is a formula that uses the preceding term to define the next term of the sequence. So let's say you had a sequence that said 3, 5, 7, 9, so on and so forth. If you look at your sequence right here, this means that a sub 1 would be 3, right? So if I were to tell you what the sequence would be, I would say that a sub n is equal to 2n plus 1. All right, now let's try this and see if it's really true. Is it really equal to 2n plus 1? So this is the first term of my sequence, so I would do a sub 1 equals 2 times 1 plus 1. 2 times 1 is 2, plus 1 is 3, right? So that works. Let's look at 9, which is our fourth term of our sequence. So a sub 4 equals 2 times 4, which is 8, plus 1, so I get 9. So this is an explicit formula, and this works for n is greater than or equal to 1. Because we only look at the terms we're looking at the first term on. You can also do the same formula for 0 on, and that's fine, it's up to you, but for this problem it starts at 3, which is my first term, okay? Now, you can't do anything less than 0 because there's no such thing as a negative term in your sequence. Now, a recursive formula is a formula that uses the preceding term to define the next term of the sequence. So if I'm on the nth term of my sequence, that means that the next term would be the n plus 1 term, because it's one more than the preceding term. So what this means is that I'm going to figure out the next term of my sequence by taking the first term, or not the first term, the preceding term, which is a sub n, because this is the term that comes before a sub n plus 1, and see what I need to do to it to get the next term. So for example, the first term is 3, to get to the second term I have to add 2. The third term is 7, to get to the fourth term I have to add 2. So each time I'm adding 2. So this formula is going to say a sub n plus 2, because this is saying that you add 2 to the previous number to get the next number in your sequence. But we have to define a couple things. We can't figure this out unless we know what the first term in our sequence is, or what some term in our sequence is. So we're going to say that the first term is 3. So let's try to figure out what the second term would be. So if the first term was 3, that means that the second term would be 3 plus 2, which is 5, so it works. And we also have to say, so this is 4, a sub 1 equals 3, and n is greater than or equal to 1. Okay? Hopefully these definitions make sense to you. We will be getting more in depth with these types of examples. All right, so consider the sequence 5, 8, 11, 14, 17. What do you think is the next number in the sequence? I want you to take a couple seconds and figure out what the answer is. Hopefully you got 20. And then I need to write an explicit formula. Now, one thing that I forgot to mention here is that this explicit formula I can use to find any term in my sequence. This one I can only use to find the next term in my sequence. So for example, if I want to figure out the 100th term in my sequence right here, I can just figure out that a sub 100 equals 2 times 100 plus 1, which means that I end up getting 201. All right, so this answer right here is going to be 201. Now, in question, or in the recursive formula, the only way I can find the 100th term is if I know what the 99th term is, and then I would just add 2 to it. So if I knew the 99th term was 199, then I would add 2 to it to get the 201 that I want. Okay, so in this example right here, I have to figure out what a sub 0 is. I know what a sub 1 is. I know that a sub 1 is 5, and I also know that the pattern is going up by increments of 3, which means that a sub 0 has to be 2, because 2 plus 3 is 5. All right, and then I have to figure out what the slope is, and I know the slope is 3 because it's going up by 3. So that means that my my explicit formula is going to be a sub n equals 3 per term in my sequence, right, plus 2. Okay, and this is for all values of n greater than or equal to 1, but these have to be integer values of n. Okay, now find a recursive formula for the sequence. So I want to know, how am I going from one term to the next, to the next, to the next? So the following term in my sequence, so for example, I know that the answer to this was 20 because 17 plus 3 is 20, means that I have to take the previous term, remember, which is a sub n, and then I would just add 3 to it. But remember, I have to define what a sub n is, so what a sub 1 is. So a sub 1 is equal to 5, and n has to be greater than or equal to 1. Okay? Hopefully that makes sense to you. This should say 4. And we will get, again, more in depth with this information in the next couple of days. So if you notice in the previous example, our operation is addition because we're adding 3 to each term to get to the next one. So what would happen if we were to change the plus sign into a minus sign or a multiplication sign or a division sign? So if you notice, this sequence right here, this recursive formula, is almost exactly like the previous one, except it's subtraction instead of addition. So if I want to figure out, for example, what a sub 2 is, or a of 2, that means that I would need the previous term, which is a of 1, and then I would subtract 3 from it. So I would end up getting, I know a of 1 is 5, so I would end up getting 5 minus 3, which means that my answer would be 2. Okay? So remember, every term is just 3 less than the previous term, which means that my sequence would just be 5, subtract 3, I get 2, subtract 3 again, I get negative 1, keep going, and that's my pattern, negative 4, negative 7, so on and so forth. Okay? So that's my sequence. Go ahead and try B, press pause, and then when you're ready, come back and see if you get the same thing as me. Okay, before we do B, if you notice, this says a of n plus 1 and this says a sub n plus 1. They mean the exact same thing. You're seeing it both ways, so you understand that they are interchangeable. So if I want to figure out what a of 2 is, a sub 2, I would figure out what a sub 1 is, and I would multiply it by 3. So a sub 1 I know is 5, so I would just take 5 and multiply that by 3, and I would end up getting 15. So each term is 3 times larger than the previous term. So that means that my first term would be 5. Multiply that by 3, I get 15. Multiply that by 3, I get 45. Multiply that by 3, I end up getting 135. And then multiply that by 3, and I will get 405. All right, so this is the pattern that I get, and this is the sequence that I get based on the recursive formula that's given to me. Okay, now question C, instead of multiplication, addition, or subtraction, I'm just going to do division. So if I want to figure out what a sub 2 is, all I would do is take a sub 1 and divide it by 3. So I end up getting 5 divided by 3, which is not evenly divisible, so I'm going to say it's 5/3. So I know this answer right here is going to be 5/3. Okay? So then, in order to figure out the next one, I would have to divide 5/3 by 3. But remember, when you divide by 3 and you're dealing with fractions, it's the same thing as multiplying by the reciprocal. And the reciprocal of 3 is 1/3. So it's 5/3 multiplied by 1/3. So I end up getting 5/9 right here. All right, and then I would do the same thing again right here. I would take 5/9. Remember, when you divide by 3, it's the same thing as multiplying by 1/3. So I would end up getting 5/27. So if I were to write out my whole sequence would be 5, comma, 5/3, right? And then the next term would be 5/9, 5/27ths. And without using your calculators, I want you to use your brains. I want you to think about what the next term is going to be in your sequence. If you notice, the denominator is getting tripled each time. So you should end up getting that 5/81 is the next term in your sequence. And we could keep going, but I think that's enough, and we'll just say dot, dot, dot to indicate that it keeps going. So after these examples, hopefully recursive formulas make a little bit more sense. All right, so in question number 3, I need to find an explicit formula and a recursive formula. Remember, explicit is where you can find any term in the sequence, so it's just going to be a sub n equals, and then I have a formula where I can just plug it in and figure out what the answer is no matter what number it is in the sequence that I'm trying to figure out. Now I know what a sub 1 is. I know that a sub 1 is 7. And then I have to figure out what the sequence is doing. The sequence is adding 4 each time. So based on that, I can figure out that a sub 0 is going to be 3. And then I also know the slope is 4 because it's adding 4 each time. It's going up by 4 for every one. So that means that my recursive formula is going to be my explicit formula is going to be a sub n equals 4n plus 3 for all values of n greater than or equal to 1. Okay? Then question B asks me to write a recursive formula. So to find a recursive formula, I have to figure out what each term is doing to get to the next term, and it's just adding 4. So I'm going to take a sub n plus 1, and I'm going to say that's equal to a sub n plus 4 for, F-O-R, 4, a sub 1 equals 7, and n is greater than or equal to 1. All right? Hopefully that makes sense to you.